All right. Hello, mathematicians. This is the video for the first review sheet. And if you feel great on this review sheet, you are going to feel great on the quiz at the end of the week. So make sure you're giving this your full attention. All right? Okay, here we go. Number one, the first one says multiples. Most people think of multiples as skip counting. So let's go ahead and skip count by 3. And it doesn't matter if you start at 3 or start at 6 or start at 30. So 3, 6, 9, 12, 15. Maybe you went all the way to 18 if you started at 6. You can also think 3 times 1, 3 times 2, 3 times 3, 3 times 4, and so on and so on. Okay? All right, let's do the same with 6, which is really, you'll notice, every other multiple of 3. So I'm thinking 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5. And again, if you didn't start at 6, you might have gone all the way to 30. And of course, multiples can keep going. So if your list looks a little different than mine, that's totally okay. All right, multiples of 13. This might get a little bit difficult for you to do in your head, so you might want to show a little bit of work off to the side. So 13 times 1, 13 times 2. If you have a hard time counting by 13s, then maybe I'll see a few addition problems off to the right. So if you take the number before and you add 13, there's my next number. Take the number from before and add 13. There's the next number. Again, take that number from before and add 13. And if you didn't start at 13 and you started at 26, you might have even gotten this far, okay? So again, we're counting by 13. And finally, at the bottom, 22 times 1. If you added another 22, that's 22 times 3. And I bet kids could get about this far totally on their own. And again, you might want to do a little bit of work off to the side. So let me add another 22 to get 110. And if you didn't start at 22, but you started at 44, let me add another set of 22, just in case you need to see that. Okay? All right, so multiples, a lot of people think of it as skip counting, but you also could think 22 times 1, 22 times 2, 22 times 3, 22 times 4, or adding 22 every time, and so on and so on. All right, let's look at factors. Okay, factors are the numbers that we can multiply together to get 9 or 12 or 17 or 36. Okay, let's start with 9. Can you do 1? Duh, 1 times 9. 2 does not work because 9 is not an even number, but 3 works, 3 times 3. And it's okay if you have it kind of listed in a rainbow way like this. You also could have it, paired up with factor pairs is fine. All right, if it was only 1 and 9, it would be a prime number, but it also has 3 times 3. So that makes it composite. All right, factors of 12. So we're thinking what times what equals 12? You can also list them this way. 1 times 12 works. Duh, 1 always works. 2 will work since 12 is an even number. 3 will work. Does 4 work? 4 is already there with 3. That's when you know you have them all. So remember, if it's more than just 1 times itself, it's a composite number. All right, the only way to get 17 is 1 times 17. It has 2 factors. Each number is a factor. So we should be thinking 17 is totally a prime number. 1, 2, prima donna. Okay. And finally, 36. There are a lot of them. I wouldn't be surprised if some kids missed some. All right, we've got 1 times 36. 2 will work since 36 is even. 3 times 12 works. So I always try 1, then 2, then 3. 4 works. Okay, 5 does not work. 5 times 7 is 35. Close, but not quite. 6, 6 times 6. And then you might say, does 7 work? No. Does 8 work? No. Does 9 work? Yes, but 9 is already there with 4. That's when you know you've gotten them all. Definitely, if it's a longer list of factors, choose that longer word. All right, for number 3 and 4, it says to write a new prime number or a new composite number, you just have to write a number that's different from one of these, okay? So your answer might totally be different than mine. I think I'm just going to say my prime number is the number 5. And how do I know it's prime? It has only 2 factors. And you could even list the factors 1 and 5 because 1 times 5 is 5. Okay? Think about how many times we flip our hair, right? 2 times because it has 1, 2 factors. You don't have to have this number. You could have something different if you wanted. It just has to be a prime number. All right, a new composite number. How about I go with the number 10? All right, so the reason that 10 is composite is it has more than 2 factors. And again, you could also list them, okay? It has 1 and 10 and 2 and 5. And you could show that as 2 little multiplication problems if you wanted as well. So again, it has to be prime, it has to be composite, and it just needs to not be one of those 4 numbers from up above, okay? Since we already kind of did that together. All right? So if yours is a little different, no problem. Let's go on to page 2. Okay, multiple choice. It says circle the 2. Let me get the focus here. Circle the 2 equations that best represent this situation. So I'm going to be circling 2 of those letters. Tito picked 27 apples. That is 3 times as many as his little brother picked. So I know that his little brother picked 9. So Marco is 9 because 9 times 3 is 27. So make sure you read that correctly. Tito picked the most because that is 27. That is 3 times more than his little brother only picked 9. So I'm looking for 2 equations that will give me an answer of 9. Okay, so look at that variable. And if 9 works in place of that variable, that equation will work. All right, is 27 divided by 9 3? Yes, it is. Is 27, oh, sorry guys, the focus is a little off. Is 27 minus 3 9? Nope. Is 27 times 3 9? Nope. But is 3 times 9 27? Yes. So A and D are the correct answers. All right, let's look at number 6. Number 6, we have to draw an equation. I wonder if anybody yelled out equal sign and scared their family. All right, here we go. Trevor is 15 years old. Trevor's uncle is 3 times older. So we're going to write 15 times 3, and maybe I'll use the letter U for uncle. So there's my equation. And then I have to figure out the answer. To find 15 times 3, there's lots of ways you could figure it out, but you might just do 15 plus 15 plus 15. So I think that's what I'm going to do. And I get a final answer of 45. So the uncle is, we want to write it, and we want to label it. You will get a point for labeling it. So either 45 years or 45 years old. So make sure you have an equation. I like using a variable. It's good practice for when you start doing more algebraic things, and then solve for the answer. Rachel bought boots and a shirt. The boots cost 5 times as much as the shirt. Boots can be expensive. The shirt cost $13. So $13 shirt, and 5 times more than that is going to be how much those boots cost. 13 times 5, you could do 13 plus 13 plus 13 plus 13 plus 13. Sometimes kids will multiply 13 times 10 and then cut it in half. Maybe you will count by fives, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. You could count by 5 13 times, okay? I've also seen kids do something like this. And if you know how to multiply, of course you could do that. And we're definitely going to learn lots of multiplication things a little bit later, not too far from here. All right, 13 plus 13 is 26. 26 plus 26 is 52. And then I need to add that final 13 right there. So 52 plus 13. And it doesn't matter how you figure it out, but you should get an answer of 65. And you could label it with the word dollars. You could also just use a money symbol as your label. Okay? All right, moving on. Fill in the blanks to complete the ratio table. The most important number on this ratio table is the number 12, because for every student, they need, for some crazy reason, 12 folders. That seems like a lot. All right, so we're going to take our top number, our students, and multiply by 12, and that'll give us that bottom number, okay? So if you want, you could draw that little loopy thing in. Sometimes that helps kids keep track of everything, and they make a little times 12. 2 times 12 is 24. Okay. And then you could think, what times 12 is 60? And it doesn't always go in order. So notice they skipped a couple. 5 times 12 is 60. Okay. And when you're here in class, you'll have those monsters to look at, those multiplication monsters. Okay. Next one, 9 times 12 is 108. And then finally, what times 12 is 120? And the answer is 10. So make sure that you're multiplying by 12 each time. That's the most important number in this particular ratio table. 1 times 12 is 12. 2 times 12 is 24. 5 times 12 is 60. 9 times 12 is 108. And 10 times 12 is 120. All right, think, how are you doing? Do you think you're going to feel great on the quiz later this week? All right, on to the back, the last and final page. Write and find the missing dimension. So this is just a visual representation of multiplication. So I'm thinking 12 times 4 equals 48. And then I'm thinking 5 times 6 equals 30. So multiplying the length and the width will give us the answer in the middle. All right, the final questions, lots of multiplication things. Most are multiplication facts. 5 times 9 is 45. 8 times 10 is 80. Get that to focus here. It will in just a second, I'm sure. 8 times 9 is 72. 9 times 3 is 27. I'm going to skip this one and come right back to it. You ready? 6 times 8 is 48. 7 times 6 is 42. 10 times 6 is 60. And 40 times 2, a lot of kids might just think, what's 40 plus 40 to get their answer? To get 80. All right, let's look at this one. How many 50s are in 400? I've also seen kids say, well, 5 times 8 is 40. And then I can see that there's an extra 0 here and an extra 0 here. Okay. You also could think, how many 50s does it take to equal 400? Well, 2 50s is 100. And then you can kind of get up to 400 that way. But the answer is 8. All right. Let me show those answers real quick again for kids that are just using the end of the video. Okay. Let me focus. All right. Here's page 1. Okay. Page 2. and the last page. All right, kids, I hope you felt really great on all of this. I will see you in class.